Hi, I'm again. I will be presenting my power electronics project, which is a flyback converter. The requirement for this project is 5-volt input and 23-volt output flyback converter, an isolated flyback converter, and the switching frequency around 100 kHz region. It can be anything over audible range. The design should use this specific Texas Instruments integrated circuit, and the feedback to the regulator should be over an optocoupler since this is an isolated design. The design template is actually provided to us. We just need to select the component values, which after selecting some parameters, for example, the switching frequency and peak current value over the transformer primary, we can easily find these values. For example, the snubber Zener voltage is selected as 30 since the maximum this regulator can accept is 40 volts, and VD plus the snubber voltage should be around 35 volts. After again selecting some values about the flyback converter, we can easily find the duty cycle and delta 1 and delta 2 values. And from these, we can calculate the primary inductance. Using the primary inductance and the before selected and V output reflected over V output ratio, we can find the L2 inductance. And if we know the core properties, we can find N1 and N2, which are 12 turns and 37 turns. Then we can easily select the timing, capacitor, and resistor values as well from the datasheet. And theoretically, the power dissipated on snubber becomes 330 milliwatts. The input power is 1.3 watts, which makes the efficiency around 61%, and the minimum load resistor for this is 500 ohms. This is the simulation results. We are looking at the output voltage, switch voltage, everything seems fine. Then I designed the transformer itself, which had a coupling coefficient of 97.5%. And I designed the PCB, which was 50 millimeters by 50 millimeters, and it's the exact circuit given before. I assembled it as given in these images here, and the output voltage is almost exactly 23 volts as shown here. And after some measurements, we see the output ripple and startup transients. And as a result, we have a 50 millimeter by 50 millimeter PCB with a very accurate output voltage, 40 kHz switching frequency, the output power of 774 milliwatts, and an efficiency of 60%. Thank you for listening.